Hey, what's up, my homies? I just figured out the QQ plot and the goodness of fit test, and I might have had a mental breakdown over how to calculate a z-score, but let's go. So first off, wow, it's not letting me turn off around the camera, just a second. So first off, we're going to go ahead and calculate our z-scores. The first thing we have to do to calculate our z-scores for the QQ plot is by calculating our sample mean, where we're going to take the average of our tornadoes, how many were in each year, and then calculate our sample standard deviation the same way. Once we calculate our sample standard deviation and the mean, all we're going to do is do our x minus the mean divided by the standard deviation. And then we'll do that for each of those points, resulting in these lovely z-scores. So next, to plot our QQ plot, we're going to graph it like a scatter plot, where our number of strong tornadoes is going to be our x-axis, and our z-scores are going to be our y-axis. All you have to do is highlight all of those, go to Insert, and then click on the scatter plot. You'll notice that they come out looking like this. So it looks like our data right here is very normal, like arrow straight line. And then right here, it does look like we have a huge outlier at the 137. That is in year, where is it? 1974. And you see here, even on the this, it looks like a huge outlier. And so if I were to do this test, I would take out the outlier, but c'est la vie, we're going with it. Next, let's go ahead and calculate our frequency histogram. So what we're going to do is we're going to take the max of our data, the min, and then do the max minus the min to calculate our range. Next, we'll determine the number of classes. I chose 7 because 7 divides into 119 perfectly, and so I chose 7. That gives us a class width of 17. From that, I went ahead and calculated the upper class limits by taking our max and then subtracting 17 from each of them. After we calculate the upper class limits, we're going to be using the equals frequency to calculate the frequency of each one. So with the frequency function, all you have to do is hit enter once, and then it will auto-populate the rest. Once we have our frequencies figured out, all we have to do is calculate, create our frequency histogram right here. So looking at this doesn't look very normal at all, where most of our tornadoes are in the 35 range, and then as we get to 137, very few tornadoes out there. Okay, so now that we have that, that is our histogram. Now to do our goodness of fit test, let's go ahead and look at, we're going to go ahead and copy our upper class limits and our frequencies down here again. Next, what we're going to do is we're going to calculate the left tail area, where we're going to do our equals norm.dist, where we have our upper class limit as our x, the mean, and the standard deviation, and then we're going to make it cumulative. We'll do that for each of the class limits to calculate what the left tail area of each point should be under the normal distribution. Now what we're going to do is we're going to calculate how much of that area is between the upper class limits. So for example, if we're looking from 52 to 35, then how much area falls between that? So what we're going to do is we're going to take our 35, the area for that, copy it over, and then for the rest of them, we're going to take the upper class limit of the next class and then subtract the previous class to give us the area under each section. And so now that we've calculated those areas, we're going to multiply each of our areas by the total frequency to give us the expected frequency under each curve. So that would look like our total frequency, which is 61, multiplied by the area under each curve. Now that we've calculated the expected value, all we have to do is take our original value minus the expected and divide by the expected. So our original value will be the original frequency subtracted from our expected frequency squared divided by the expected frequency. And so when we do all of that, we are going to look, so now that we've calculated that, we can calculate our chi-square test statistic, where we're going to do the sum of all of these. That chi-square test statistic is 31.06. Now, looking at these values, it looks like we have a huge outlier right here with our one value falling within the 137. And so just having that value right there makes me wonder, like, I wonder if these values actually are not as normal as they appear to be. Because when we plug in our chi-square test statistic into our p-value, where we're going to do our chi-square.dist, where we have our x and then the degrees of freedom, to calculate the degrees of freedom, we're going to take our n, where we take all of the expected values that are greater than 5, which is 18, 17, 14, and 7, and make those one each separate classes, and then all of the expected values that are less than 5 are going to become one class. So that gives us an n of 5. We'll plug that into our chi-square distribution, which gives us a p-value of 99%. If you remember, the null and alternative hypotheses for this test is that the frequency distribution is the data is normally distributed, and then the alternative hypothesis is that the data is not normally distributed. And so I have the hypothesis that if we took out the outlier of the 137, that we would get a completely different answer that matches what our histogram looks like, where our histogram is showing something that is not a normal distribution, where our goodness of fit test and our QQ plot are showing normal distributions. And so, yeah, that is everything, you guys, and I hope you have a great day.